Hello, everyone. I'm Joseph Knight. I actually go by JBK. I decided to do that a few years ago because going by Joseph Knight your entire life gets kind of boring. So I started going by my initials. I'm with Hewlett Packard Enterprise. I'm our chief field technologist for service providers. And my role within Hewlett Packard Enterprise is to make sure that we're listening directly to service providers and bringing solutions to market in a timely manner to meet the very progressive needs of the service provider community. And that ranges from the largest of T1s to the T2s to the emerging T3s. Also, you can tell that I do not have a beard anymore. That's who I am deep down still, but my partner told me it was time to shave because she had enough of the experiment, so I decided to shave to keep that relationship healthy. I'm going to cover today not a deep dive economics view of standardized server modularity, but just where we think this economy is going, this ecosystem is going. So more of a foundational overview of what is going to create something that's going to be very beneficial for the market, for vendors, suppliers, and ultimately customers. I think it's good to start where, what was the original driver for pushing server disaggregation down to a module level? Well, if you think about application development, where a lot of, again, the segment I support, service providers are, they're around service delivery based on application development and time to market with advancements there. Now, if you're as old as I am, which 26, 27 years old, depending who you ask, back in the late 80s and 90s, it's a very monolithic approach. You had a C++ code base of millions of lines of code, and you had all these individual functions that were tied together in a common code base. If you wanted any of those functions to evolve independently, it took a lot of regression testing against the other 1.5 million lines of code to allow that new function, let's say in delivery or payment, to come forward. And it wasn't a 6 months introduction. It was waiting for SAP version 4.5 or Oracle Apps version 6 point whatever on a 2 to 3 year life cycle. Well, in the service provider space, the demands of customers are a lot more aggressive. They're looking for advancements, business enablement that is going light years faster than what that monolithic base could support. Thus, the creation of microservices in a cloud-native sense, a disaggregation of those functional levels into independently growable, advanceable entities. Now, that starts leading into the economics of that shift, in that now you're not spending time developing the fundamental code base in-house. You're leveraging an open source ecosystem and using the community to advance code functionality, bug fixes, et cetera. And that's allowing you as a service provider or customer to concentrate your intellectual property higher in the stack, increasing your ability to deliver services. So no longer are you spending fundamental time at the microservice level, at the code level. You're creating those ties together among microservices to make sure the user experience is as rich and timely as possible. The natural progression of that is pushing that philosophy down in the stack. And that's all about what DC-MHS modularity is. It's disaggregating everything from the PCB and the PCA, whether it be tied on there physically through traces or connected through proprietary connection mechanisms, disaggregating that into modular entities. And so the same economics apply in that if you're not spending time on things that are not higher value, if you're spending time trying to maintain just the fundamental action and interconnectivity of modules, you're not creating value quickly enough to your customers. You're spending time on plumbing versus value. So from an economic standpoint, economics is all around supply, demand, cost, benefit, behavior-driven pursuits, things like that. That's, in fact, my wife is an economist, and I learn a lot from her, and part of why I put this presentation together is understanding what standardization does to behavior. So if we break this down, disaggregation to a module level creates markets and expands markets. So no longer are we looking at OEM. I'm an OEM, a part of OEM, Hewlett Packard Enterprise, of course you know our competition. No longer are you having a limited market where service suppliers are counted on one hand. You now have a new market creation where multiple vendors and suppliers are creating the individual module elements. So take for instance, now you have a processor company like Intel, AMD, Ampere, you name it, creating HPM reference boards, host processor module reference boards. You'll have vendors and suppliers enter the market to drive the cost down. They're going to start, you'll start seeing multiple vendors create those, instantiate those modules, and drive the cost down, because now they don't have to worry about engineering the HPM. It's already done by an Intel, AMD, et cetera. Now also it'll challenge HPE to create more innovative HPMs, create value higher in the stack. So no longer are we trying to race to the bottom from a cost standpoint from an HPM. How do we leverage the innovation zone on the HPM to provide more value to you, that you'll pay more for that value? So it creates a new market for the individual modules. The DC-SCM, it could be actually the most important part of this market creation. The DC-SCM is a secure control module. It's going to be the most important part in the DC-MHS ecosystem to bind these modules together in a secure fashion. So market creation on how you bind a server together and where you add value to customers in doing that, we see that market being created very richly. Expansion of markets, backplanes, risers, chassis, cabling. So, you know, now as an OEM, what we do is we try to bring to market, for example, backplanes that accommodate OCP slots in the front for front I/O, ready to accommodate those CXL, CMM modules in the front. Some of those require by-4 connections to NVMe drives. Some of them are by-8 for CXL. Oh, by the way, I need a PCI Kim slot for my DPU. So you have like multiple permutations of backplanes that we as a company have to foresee. Well, if you're in the DC-MHS world and you comply to MXIO in terms of the connectivity, in terms of signaling and sideband, if you're conforming to plug and play, the plug and play work stream in terms of how do I recognize what you are as a backplane, and how do I control your CPLD for or LEDs and things like that, if that's part of a standard, then HPE can go to the market and then leverage the innovation that's already there without having to spend our time when there's so much more available in the market. So you can kind of see where this is going. Same thing with risers. Now risers fit into a multi-track slot. So now you have a market creation or expansion of risers. So if you want that CXL memory module, your particular use case requires a CXL memory module that's in a PCI Kim form factor. Oh, by the way, I need an extra slot for my 200 gig DPU. There's going to be an expansion of markets for riser vendors and suppliers to create those, lifting the burden off of companies like OEMs so we can concentrate on higher in the stack value. And standardization elevates innovation. It just does. It takes, like I said earlier, it takes the mundane resource investments off of your shoulders. No longer do you care about optimizing pin counts and impesty or protocols or the mechanical and electrical connectivity. Now the innovation is higher in the stack and the modules. And what that means is, and I think I have this on the next slide, what that means is it's allowing OEMs, ODMs, and all these vendors to create value that's closer to outcomes for you as a customer versus spending all of our engineering resources on trying to figure out what the best GPIO route is from point A to point B. Competition is the cornerstone of an economy. Competition creates options and it drives costs down. And modularity will drive that cost down and again, open up opportunities to create value higher in the stack, closer to value and outcomes for your customers. Now, I already mentioned some of this, and as I'm talking through this, obviously some of these concepts overlap and interleave. And I've already mentioned the top two there, and the very bottom one is very important as well. So now you have the ability to evolve these modules independently of each other as a customer. If you don't need PCI Gen 6 EDSFF NVMe because you don't need 64 to 128 gigatransfers per second, keep that investment in your disk cage for EDSFF and advance the other modules that might make more sense for you, and or redeploy those modules to other areas of your business that don't need the latest and greatest, but good enough compute is fine. So redeploy, reuse. And then finally, the important part of this is what's going to drive the economy is for customers and large enterprises, T1s, to start prescribing conformance. So customers that understand that if you have a standardized base and you can create competition, the way to start that market is to prescribe in your RFPs and RFIs that you must adhere to DC-MHS. So instead of hardware specifications coming out saying, here's my 7,000 page document of what I want in a server, you could do that, but start doing it at a modular level, prescribing adherence to MXIO, SDNO Class B, plug and play version 3 point whatever it is, and that way you're now bidding out and awarding business potentially at the module level, not the whole server level. So instead of having 2 or 3 ODMs or OEMs that can respond to your RFP, you now can have a whole market responding to individual modules. And then system integration becomes a line item. Maybe for Hewlett Packard Enterprise, we're no longer a traditional server manufacturer. We're the best in class value when it comes to system integration. Because now we take all those things from these various vendors that save you money when you award them the bid and say, HPE, I like your DCSCM value. I need you to integrate this, prove it in a secure fashion, and bring it to me as an integrated product. I already mentioned this again. Some of this bleeds over. I know I only have 15 minutes, but so some of these thoughts and these concepts bleed over. And I've already mentioned the fact that this needs to be driven by customers and again, in my space, T1s and T2s prescribing adherence. If you don't prescribe adherence to modularity, it doesn't create this economy. So once that happens, the role of cost pushing down, innovation rising, starts to happen naturally just based on, again, fundamental economics. And now, the other thing that's really important is commercial off the shelf. So suppliers and vendors benefit. No longer, again, are you waiting for hardware specifications or trying to react to what you think customers need. You can start in advance in creating a portfolio, a catalog of HPMs, a catalog of backplanes, a catalog of risers that you know can be reused in a DC-MHS world or choice. So now customers come to you and look at your catalog to find the best fit for them at the right cost. So again, not an advanced course in economics, but this is where the basis is and how we see behavior starting to be driven to benefit customers and suppliers alike. So thank you so much for your time. Hopefully this was a little bit valuable. Again, JBK, you can reach me at jbk@hpe.com if you need to get a hold of me. Thanks so much for your time again. Sorry.